Before I start, I really want to thank the organizers for arranging this global summit. It's not easy, and bringing it free to us. So thanks to all the organizers and the volunteers. So let's move ahead. We'll be talking about Checkpoint and why should we care about Checkpoint as a DBA or database engineer or data professional, or whatever you call yourself. So let's get started. I'm not going to read about myself anymore, but you want to take a note of the context that I put on the left of this slide. So if you have any follow-up questions, any comments, or something that I was not clear, or I ran out of time, please do reach out to me, and I'll be happy to answer those questions. I also uploaded the slide deck and all the demo code where the organizers asked us in a OneDrive. You can download it from there. I also have it in my GitHub repo. You can download, edit, use it, distribute, whatever you want to do. So before I get into the topic, the first question we need to ask is, why do we need Checkpoint, right? If we cannot appreciate or do not appreciate the reason of Checkpoint in SQL Server database, the talk wouldn't make much sense. So I'll go briefly. And there are a few more slides to talk about that will lead up to talking deep into the Checkpoint. And I'll also have two demos that I'll show you some of the stuff that I'm talking about. So why do we have Checkpoint? There are three primary reasons that we have Checkpoint. One is to guarantee durability. And what does that mean? I'll talk about more in details. To reduce crash recovery time. Now, what is a crash recovery? It can be, it's a generic word, I understand, but it can be anything from a power failure, network failure, server going down, storage issues, or whatnot, right? So we can quickly recover. The number three reason is to batch the IOs for a better disk performance or a better write performance. What do I mean by that? If you are updating a 1000 record, would you prefer to write 1000 times to your disk, or you prefer to write it one time in a bundle, all 1000 updates, but still want to make sure that once it's committed that you didn't lose your updates, right? So it will guarantee that, but it will write it in, only in one shot. And how SQL Server does that, we'll talk a little bit more into details about that. Now, what is a checkpoint, right? So in a very simple English language, it's three things. First, it creates a known good point. Now, why does it create this known good point? So in every database, there is a book page. It's a file number 1. I believe the page number is 9. I can be wrong. In that page, in the book page, it keeps a record of the log sequence number. And from that point, and it gets updated all the time, and I'll show you some of this stuff in the demo. So from that good point, if we have a crash, it will start applying the changes when it's going to recover the database. So that is the primary reason that frequently SQL Server database do a checkpoint, so the recoveries are quicker. Now, I talked about durability. So why does that? I talked about three things, right? Why do we need checkpoints? The first one I said is the durability. And the durability actually comes from the ACID property that is maintained. And ACID property is not really specific to SQL Server. Pretty much any relational database system kind of honored these properties. And there is some history behind it. In 1983, Andrews Reuter and Theo Harder, they actually came out with this acronym. But if you read some of the literature, some people will say that, Jim Gray actually mentioned some of these properties, the three of those, except, the third one, he mentioned a lot earlier, but the fourth property was not mentioned, and it was not, it was not officially kind of published. And And there is some talk about IBM used it even as early as 1973. So if some of you are interested in the history, I put some URLs at the end, you can go and read about those. So the first one is an atomicity. So what do we mean by that? It means that if I have a transaction that composed of multiple statements, I want to make sure that everything got.
Hi, Taiob. Sorry to interrupt
Yes.
you. Just that some background noise is coming constantly. Audience are just messaging in the platform. So we can do a check now once.
Yes. Are you still getting it or?
Yes. So whenever you speak, some background noise is coming with that along.
How about now? Any better or no?
Yeah, it's still there.
So I'm going to switch to a different mic. I'm using this same for any better?
Yeah, a lot better. Sorry, please continue.
Hold on, I have to.
Yeah, can you hear me?
Just give me a minute.
Okay.
Okay, can you hear me now? And is it better?
Yes, a lot better now. Please go
okay, sorry about that. Okay, so the first one I was talking about atomicity. So it means in a transaction, if we have multiple statements, atomicity will guarantee that they're either all executed or none. A typical example that we give, if you are transferring money from your bank accounts, you do not want to withdraw from one account and the server crashes, and then you see that your money was withdrawn, but it was never deposited to the other account, right? We don't want that. We want everything to happen. And if there's a failure in between, everything should roll back, whatever happened, right? Whatever portion was done should roll back. Next one is a consistency, which is, I think, more, a little bit more confusing, or a little bit confusing among all the four that I will be talking about. So consistency, and do not confuse this with the eventual consistent, right? So that's a term that with some of the new database systems are coming out in the market. There are different consistency levels. So there's one called eventual consistent, and I'm not talking about that. What consistency or correctness is done by either constraints, check constraints, foreign key, columns should have a default value or this range value and all that. So these are all mechanisms to have correct data. The next one we're going to talk about is isolation. And the isolation is done, it's a fascinating topic, is done by locking mechanism within the SQL Server. And it is done so you do not see someone else's unfinished work, right? Michael J. Stewart, a good friend of ours, in his blog post, he said, not looking at work in progress, right? That's what isolation does, right? So if I'm in the middle of transaction, I'm modifying data, I'm half done, I do not want anybody else to look at that. Now, does it happen all the time? No, there is one isolation level called read uncommitted, which actually breaks this rule that what I'm talking about, but it is also there for a purpose, but you just have to use it wisely, and you have to know when you are using it. The last one is a durability, which I talked about before, and which checkpoint does help in this property of the ACID, right? The durability one. And in a simple English, it's saying, if I get an acknowledgement back, so I call the database to do this XYZ, I got an acknowledgement back, it's done. Now, I don't care if your server goes down, your power failure, your has a hard crash, I'm guaranteed that that data is persistent in your database.
Now, to do that, as I told you, that SQL Server does not write every change to the disk right away, right? It bundles those. We talked about it. So how does SQL Server takes care of it? There's something called write-ahead logging, which we'll talk a little bit more details. And there is a recovery phase. There is an undo and redo if we have a failure, right? When it's recovering. So it's primarily done by write-ahead logging. So let's look at that. What it does and how does it do it and what does that mean. But before I do that, I want to talk about another concept. It's called clean versus dirty page. A clean page is defined that we read from the cache, because SQL Server cannot do anything, any modification or anything, unless your data page is in memory. So if you need to read SQL Server or rewrite or modify whatever, SQL Server has to bring it to the memory. So a clean page is defined once a page has been brought over to memory, it hasn't been modified, right? It hasn't been touched. Or a dirty page has been written to the disk and hasn't been modified yet. Because you have to understand, in certain situations, when SQL Server write a page to the disk with checkpoint, SQL Server doesn't evict the page from the memory, because unless there's a memory pressure, there is another service that comes and do it, and we'll talk about that very briefly in the slides in future. It's coming up. But during the checkpoint, SQL Server, when it writes the dirty pages, it does not evict it, so it can still stay there. So as soon as it's written, it's marked from it's marked as a clean page. And a dirty page, as I said, it's a vice versa. Once we read a page, if it has been modified, or once a page has been written to the disk and then it got modified further, then we mark it as a dirty page. And there is a DMV called sys DMO as buffer descriptor. There is a column name is modified column, and you can use it, which you'll use it in the demo to see all the pages in memory in your buffer and which one is marked as dirty and which one is marked as clean. Do you have to keep track of it every time? No, but if you're seeing weird issues with your memory pressure or your buffer, pages are getting evicted a lot quicker, and then you might want to see what kind of objects or what pages that belong to certain objects are taking space in the buffer. So please put your questions. I'm sure the organizers are probably following the question answer. If you have any questions, comments, please put it there. I can also take a look if you put in the chat, and I'll answer those. So write-ahead logging. This is a unique technique that SQL Server does. And let's go to the next one. And so this will give us a little bit more details. I know there's a lot of boxes. I'll try to go and explain this and see how this works. So for example, just for hypothetical, just for the sake of this talk, if we say update table, table A, set column 1 equals some, say, get date. And this table has millions of rows. And now we want to update all these columns for whatever reason. So what does SQL Server Engine does once we issue this command? First, it has a begin transaction. So even if we do not say begin transaction, SQL Server actually starts a transaction. And there are differences between explicit and implicit transaction. I'm not going to go get there now. Once we begin a transaction, SQL Server checks the pages already in memory or not. If it is not, then it's going to fetch the page from the disk to the memory. At that point, SQL Server is going to put the lock as soon as it's getting from the disk. And when it is changing the data in the memory, it also does something called latch. So latch it's a lightweight lock. It's a shorter period. It actually just protect the physical structure of the page, but the locks actually, even if you're not making any change, your transaction is open, the locks are going to get held, so nobody else can take another computable lock, another lock which is not computable on that page. Once it does that, then it generates a log record about the change, right? And then it also update the page with that log record, that this is the last log record that has a change on this page. Then it's going to change the page or update that column in that page. As soon as it does it, now this page is marked as a dirty page, means I'm already modified, right? And so the copy in the disk and the copy in the memory right now doesn't match. So once that data is modified, the latch is released, but the lock is not released. Then it's going to repeat for each page because I said we have millions of records. So once all of this done, then all these change records is going to flush to the disk. It's going to release the log from the page and is going to send a signal that this transaction has been committed. So now if you look at all these steps that I've been talking about, I only said that the log records that has the change details has been flushed to the disk. So does that mean that I forgot a step to flush the data page that I modified in the buffer? No, I did not. And that's why it says write ahead logging means, the logs will get modified, but your pages doesn't need to be more change in the disk every time. And at this point, if SQL Server crashes, there is a way to recover because your logs are already hardened in the disk, and we'll talk about that. So on a side note, I know we're talking about checkpoint. We are not here to talk about lazy writer or eager writer, but just so you know, all these three processes or the other two processes beside checkpoint also write dirty pages to the disk. And I'm not going to go into details of those two because that's not a part of this talk today, but I want you to be aware. And one common thing about all three processes are they all use asynchronous IO. What does that mean? Means once they issue a IO to the operating system from SQL Server OS to your operating system, whether it's Windows or Linux, because now SQL Server run on Linux, it does not wait for that IO to finish. Once it's issued that IO, pass it to the operating system, that CPU can get tied to another process, keep doing the work. Once that acknowledgement come back, it does acknowledge and then it records it. So these are all asynchronous IO to make the performance better. So your CPU is not waiting for the operating system to finish that IO and give the acknowledgement right back. It will do something else in between. I'm going to just briefly talk about, there's no demo or nothing else about these things. So the lazy writer is another system process. What it does, it actually looks at the buffer and how much space we have free in the buffer. If it sees there is a pressure in the buffer, it will come and evict pages from the buffer cache, and it has an algorithm. It looks at the last uses. Based on that, it will actually clear up dirty and clean pages. So we talked about briefly about checkpoint will only touch dirty pages, but the lazy writer will do both dirty and clean pages if this pages hasn't been used or hasn't been looked up for a longer period of time. And it does have an algorithm that it, once you touch a page, it bumps you up to 1. If you doesn't for a time, it -1 and keeps an algorithm. I'm not going to go into there. So, but just so you know, the lazy writer also write dirty pages, and before it does it, it has to do everything else that checkpoint does. Means all the log record up to that point has to be flushed first before you write this page to the disk. So that always stays true, doesn't matter what system is writing the dirty pages. Other one is eager writer. So there are some SQL Server processes that we can do with a minimally logged operation that's called like a bulk insert or select into. So to speed up these processes, what SQL Server does, the same process can allocate new pages, and at the same time it actually also keep writing the finished pages directly to the disk. And again, I'm not going to go into any more details, but it does it purely for performance reasons. So we can do like bulk update, bulk inserts, and select into this kind of operations very quickly. But eager writer will also write dirty pages to the disk. So back to checkpoint. One misconception that I want to mention before I go further oftentimes you will see even mm, in blog posts, in different forums, people will talk about checkpoints, write dirty pages only for committed transaction. That is wrong. Whenever you have a checkpoint, it will write all dirty pages. Doesn't matter if the transactions that in that page is committed or it's on the fly, means it's still not committed. Doesn't matter. First, it will write all the logs up to that point to the disk, and then it will write these pages. Doesn't matter if this transaction has been committed or uncommitted, just so you know that. So what does happen during a checkpoint? So let's look at it. First, SQL Server will generate a log record about the checkpoint, and we'll see that during the demo that a checkpoint is starting. Then it will log the records. All the log records will be written to the disk. Then all dirty pages, and again, committed or uncommitted transactions, doesn't matter, will be written to the disk. Then what it does, the next one, writing to the boot page, what SQL Server will do, will take this log sequence number of the checkpoint and write it in the boot page, what I talked about before. If you have a crash, it goes and look at this sequence number, and now it knows that I have to start undo and redo from this point. I do not have to look anything before that. Now, if you're using accelerated data recovery, I'm not going to go in there. These things work in a little bit different way. There are, you can go and read about that. And there are also a couple of nice, videos by some data professionals. John Deardorff is one I can remember. He did a talk recently for one of the user group here, talking exclusively about ADR. So you might want to look that up. And once that is written in the boot page, then the checkpoint ends, and there's another log record get generated that the checkpoint ended. Now, if your database is in simple recovery, there is another step happen. So it will clear your log file. We call this a virtual log file. They will be marked to be reused. And I'm not going to again go into the details of VLF and why this is happening. If you're in a full recovery model, it doesn't happen because you have to make sure, it has to make sure that those transaction logs has been backed up before the VLFs get marked inactive. Couple of things. The IO size when it writes the pages, it's a 1 megabyte size. Pre-2016 it was 256. Also, the checkpoint can throttle itself, right? So it can throttle about how quickly it wants to write, how much it wants to write, or there is some control, and it is done automatically. So it looks at the current IO performance, and it looks at the the queue, how long it is and how long it's taking for the current IOs to perform. And pre-2016, if it was 20 millisecond or more, it will throttle, and that number has been increased to 50 millisecond in SQL Server 2016. If you're reading about checkpoint, you might bump into this startup parameter minus -k. It actually lets you to throttle your speed of your checkpoint. I have never used it. I also asked a bunch of people in social media with the SQL help hashtag to find out. I haven't found anyone really using this startup parameter, but you will run into this if you're reading the documentation. So I just want to mention it. So we'll take a small detour here, and we will go for a small demo, and then I'll come back to the slides again. Okay, so the first one, I'm just dropping a database and creating an empty database, DPS 2022 demo. I'm using a local SQL Server 2019 patched up to the latest CU, also using the latest version of SSMS. And I'm setting few things to reduce the number of log records, setting it to simple recovery, auto create stats off, which I'm not advocating. I'm just doing it for the demo purpose. And then we create a table. We're just inserting one record, just one column, keeping it simple. So now I talked about the buffer, and we can see, and sorry, I want to mention this. I copied this from Pinal Dev's blog, so I want to make sure I give credit to him from this blog post. I did not write this query. So as you can see right now, DBO schema, object name, and I have 2 pages in buffer, and both are dirty because we made a change. Now, if I do a checkpoint and then look at the log records, we see that we started a checkpoint, and this is the operation that I talked about. It's writing this checkpoint LSN to the boot page. And then the checkpoint ended. Now, if I do a begin transactions, begin tran, which is explicit transaction, here, you call this a implicit, even though we don't say begin tran, commit tran, SQL Server does it for us. Now, if I do this, and now we do a checkpoint, remember, we did not commit here, so this is still open transaction. Now you see a little bit more records, and I'm actually, just so you know, I'm actually, putting a predicate, not looking at these. The loop count delta, they are mostly for system objects that get updated and modified and all that. I'm just trying to reduce the noise to make my point. So here we see the transaction started. We inserted a row. We inserted a checkpoint. We wrote to the boot page. Checkpoint ended, but this never got committed. What will happen if this server goes down now? Because we haven't committed this, but we did a checkpoint, right? So the log records has been hardened. In this record, you will see this LSN is recorded also in the boot page, but this one has all the detail. This one has the LSN for this begin transaction. It does it in reverse order, so it's really not intuitive for you to find out. But if you search this string, it does it in another way. You will see that this LSN is here. That's how it knows that this transaction is started, but it never committed, so it will undo that portion. And now if we do a commit transaction and then do a checkpoint, now we see that we don't have those record in the log, that begin transaction and that inside, because we already committed that. And this is just a cleanup. So any question on this? Okay, if not, I'm just going to keep moving. So there are 4 different checkpoints, and the indirect one, I put it at the end because it was actually introduced in SQL Server 2012, and it became default in 2016. What do I mean by it became default? I just want to make one thing clear. Starting in SQL Server 2016, if you are creating a new database, it will automatically have indirect checkpoint turned on. But if you are restoring from an older version, even though you update the compatibility level, indirect checkpoint is not turned on. You have to manually turn it on. So there's a distinction between creating it or restoring it. So the automatic one was there for, from the beginning. It is controlled by a value called recovery interval, which is default to 0. So recovery interval 0, what does this mean, right? This means that SQL Server will try to do a checkpoint approximately, and again, I'm going to emphasize, I'm saying approximately once a minute for active database, and your recovery time is about less than 1 minute. Now, is there a problem with what I just said? Yes, there is. So how reliable is this setting, right? Number one, I said that the recovery interval will try to keep the recovery time less than a minute. So SQL Server, this is looking at a number of log records, right? But it is not looking at the number of dirty pages. So I might have log record that corresponding to many dirty pages or very few dirty pages. So this is not being considered, this is not being taken into consideration. So it's just looking at the number of log records. This is one of the problem. Number two problem is the long running uncommitted transaction, which it has no clue. So I'm sure if you're working with SQL Server for a period of time, I'm sure we all had that moment that we did a kill and then we are all waiting, right? And your boss is probably, breathing on your neck, right? When is this thing going to finish? And oftentimes people get under pressure. They say, let's just restart the server, which is the worst thing you can do, or restart the database because it is going to start from the beginning again, right? So, that's another learning you take today. Doesn't matter how much pressure you are in. If you see a rollback is happening, just have patience, stand on your ground. Even your VP is saying no, tell them no, you do not understand. I'll explain you later on when, we are over the situation, and then go and explain them how this thing works. So because of all this, and then it has no clue about your disk subsystem, right? It doesn't know how quick your IO is, how long it takes, and all that. So even if you read the Microsoft documentation, I'm just quoting from there, it says that means that the recovery interval setting is unreliable. It cannot determine an accurate recovery duration. So it's really a wild guess. There are so many variables that the 1 minute time doesn't work all the time. So do you change the default? Microsoft has some guidance how to do it with SP configure, but also have some caution that it's an advanced setting. Make sure you know what you are doing, make sure you know why you are doing it, and do not change it from from a 1 minute to a very large number. Maybe do it gradually, right? If you have a valid reason that why would you do that. Now, the next one is a manual checkpoint. So there is T-SQL that we can issue for a manual checkpoint, and there is also another switch there called checkpoint duration to tell SQL Server that I want you to finish this checkpoint within this number of seconds. It is not guaranteed, and it's an advanced option. Now, when do you use manual checkpoint? When do you use checkpoint duration? So I kind of struggled with it a little bit, especially if you are not using anything older than SQL Server 2012. Why would you use a manual checkpoint? So I know a lot of people, what we did before we had indirect checkpoints is to level the IO, right? So in order to reduce the high IO spikes, sometime we will have a SQL Server agent job actually scheduled very frequently to do manual checkpoints. And it will make sense when I show you the demo that how indirect checkpoints can help you, from your IO bursts. So I put this question in in social media, using the SQL help hashtag. If you don't know, look it up in Twitter. I asked this question, and a bunch of people, Aaron Bertrand, Travis, they responded. So from there, answer, as you can see, all of them, they never use checkpoint duration, but there were some good points came out, like planned failover. I personally actually issued manual checkpoint because I had issues with a always on availability group failover on large databases. They're over 20 terabyte and significantly reduce the failover time. And there are some improvement coming in SQL 2022 with the parallel buffer scan and all that. I'm not going to get there, but I have used it for planned failover. And then there are some other examples here for performance testing, batch loading, and then there was a point about the oldest page was holding the log reuse and used a manual checkpoint. So, but nobody used the duration. Internal checkpoint, as I said in the slide, it could guarantee disk image, same, it matches what's in the log. And SQL Server internally does these checkpoints when we do certain operations. And I'm not going to read this slide, I just put it just so you know, when you do these things, these operations behind the scene, there is checkpoint happening. So if you have issues with your checkpoint, some of these operations might run longer, like your backup, or when you are stopping SQL Server engine, it might take longer if the checkpoint is taking longer. You might be sometimes wondering that why it's taking longer. And there can be other issues. I'm not saying it's all checkpoint, but one of the point is that checkpoint may be, causing it to, for a longer duration. Indirect checkpoint, as I said, it was introduced in 2012. And this one uses actually number of dirty pages instead of number of log records. So it can, it can estimate more accurately what needs to happen. Keep number of dirty pages below threshold. So there's another setting. It's a database level setting called target recovery time. And default is 60 seconds. You can set it up with different values. It's per database. So if you're doing a backup restore, this setting will come with that. So just keep that in mind between your production and non-production environment. Just make sure that just keep it in mind that you've actually brought this setting back when you're doing a backup and restore. On the indirect checkpoints, as I said, it's default in 2016. If you are restoring, you have to manually do that. So in 2019, there was a major fix, which is a non-yielding scheduler errors. And I'm not going to go into details of that, but what I did here, this is a copy paste of a picture from this URL. And this actually explains in details how indirect checkpoint works. And there have been some improvement in SQL 2019, especially around the contention that I mentioned before. So in a nutshell, what happened is for each database, you get 128 lists that keep track of the pages. And then as soon as it realizes, the algorithm realizes that you have exceeded the number of dirty pages, it is going to go and start from the longest list to the shortest list. It go and reads and try to rearrange all the pages and then create a large size of IO and go and write those pages to the disk. Now, when you can get contention, why do you get it? This page we'll talk about more in length, and how Microsoft resolved this, I think in 2019 CU4 or CU5, I can't remember exactly. Yeah, I do not even have it in Node, but it's in one of the CU, in earlier CU in 2019 that was fixed. How do you monitor checkpoint? Now, normally, do you need to monitor checkpoints? Probably no. Does everybody do it? No, I do not all the time. But if you see an issue that suddenly your workload or your throughput is slowing down, and then you track that your writes are taking longer time, or your reads are, read writes, mostly writes are taking longer, and you have a IO burst of writes at certain interval or at certain time, by setting a performance counter collection, or even with some accident events. Once you see that, if you want to make sure that, or you want to rule out if this is happening for checkpoint or not, you might want to do what I will be talking about right now. So there is a performance counter checkpoint pages per second, but just remember this is an aggregation of all the checkpoints of all the database in an instance. So if you're trying to pinpoint to a single database, this is not a good way, not probably, this is not going to lead you to what you are looking for. There are two extended events called checkpoint begin, checkpoint end, which is nice. You can use those. There is also two trace flags. So even though I put 3605 is a very common one if you want to write output to your error log, you need that, but that's nothing to do with the checkpoint. The true trace flag that you want to take note is 3502, 3504, and I will show the what each one does during the demo. This is a question that I get often, checkpoint TempDB. So you have to remember that TempDB is in not in full recovery model, right? It's in simple recovery model. So it works in a little bit different way. But one misconception also people has, you have to remember that you can execute any transaction or do anything in your TempDB, right? Nothing stops you, right? Create a table, insert, update, delete from the table, modify, and whatnot. So even if you do a rollback, or SQL Server has to roll back that transaction, so you still have to keep track of certain transactions. But once we recycle SQL Server, we get a brand new TempDB, so it doesn't have to do a crash recovery. Just keep that in mind. So TempDB only does a checkpoint when the log file is 70% full. There is you can also do manual checkpoint, and there is lazy writer, and VLF inactive happens like any other simple recovery database. So I will, the demo I'll show you next is also going to happen on a simple recovery model database. So you can probably relate some of the stuff, and you should be able to see some of the stuff that I'm just talked about TempDB. So I'm pretty much done with the slides. Before I go further, I want to see if there are any questions or comments that I can answer. Okay, if not,
No, so far, nothing so far.
Yeah, I'll move on. Thanks. So you're going to do 3 short demos using one script. So this one, I did some setup before all of you came online, just in the interest of time. But I put enough comment, so once you get my script, you should be able to follow along with my comments, but I'll still walk you through. So first I, just a simple variable, drop database if it exists, if not, give us a statement, create database. I also did this, and again, I want to reiterate, I'm not advocating this to anyone. I'm just doing this to keep our log records to minimum. So when I'm showing you, there's not much noise there. But please do not do this unless you know why you are doing this. And then I created an empty table, and then I created a store procedure. And it is, I also took some help from this URL when creating this store proc. So it's just a random insert, update, delete. And then I'm going to use a tool called SQL Query Stress. You can get it from GitHub. This was originally written by Adam Mechanic. Now it's open source in GitHub. You can also contribute. And I have a performance counter, performance monitor open. I'll bring it here. So I have 3 counters. One is looking at disk writes. Let me maybe make it a little bit bigger. Yep. So I have these 3 counters. What I want to show you is, first I said, logs checkpoint will happen when the logs get to 70%. And then you will see the write byte will have a burst whenever you are doing a checkpoint, right? And right now we haven't touched with anything with the indirect checkpoints, right? We left it as default, right? I haven't done anything. So this is the SQL query stress tool to set up your database connection. You test it, it works good. I'm not going to go into more details. There is some documentation in GitHub. And I said I want to run this to store procedure, insert and update. I want to do it from 20 threads, repeat 100,000 times, and go. So let's put this in a scale. So as you can see from here, the blue one is a % log used. It is going to ramp up slowly. Sorry, this one, right? So as soon as it gets to 70, issues a checkpoint, it will come down. Still not, yeah, so about 70. And now let's turn on this to trace flag. We'll go back and look at that again. Let's recycle the error log. And now we did the error log. So now we can see in our error log, we can see that when the checkpoint is starting and when the checkpoint is ending, right? Checkpoint begin, checkpoint end. It doesn't give us more detail. It doesn't give us how many pages are being written, how many megabyte of data and all that. So what you can do, we can turn on 3504. Here we only turned on 3502, which gives us begin and end. Let's turn on 3504. Do one thing. I think I might have ran this. I was testing it before. I'm going to make it to default. "3504 should give us a little bit more details about the checkpoints. Yep. Okay, so we did that now. Yeah, I'm really surprised that it is not doing what I was expecting. Because 3504 should give us the number of pages and how many megabytes are written. So I will check that out. I'm not 100% sure. Let me turn this off. I'm not sure. Okay. So let's bring this up. So as you can see all this, you can see this IO bursts, these are happening, right? With the checkpoints. So now, if you turn on your target recovery time, means our indirect checkpoint just for demo purpose, to 15 seconds, we should see a different behavior now. We shouldn't be seeing these spikes anymore. Like this one, there's another one was here. As you can see that it's got leveled down a lot from here. And if we go to the other extreme, just for demo purpose, 1/22, and if we wait a little bit more, we should see a bigger spike like this again. As it goes up, when it reaches around 70, you should see a spike. Yep, right here. So as you can see here, right? So if you have issues with your workload with this kind of spikes that you want to avoid, that's when you want to play with the indirect checkpoint. And I'm not advocating that you put it at 15 seconds based on your situation, right? Whatever you want to do. So that's pretty much I had. I'm really sorry about this 3504. I'm really kind of at a loss, like what happened here, why it's not doing what I was expecting. So I need to look at it a little bit more, because I did test this and many times, and I know that 3504 give you more details, but I'm not sure what's going on here. So I'll go back to slides. I put some reference papers, I know, and these are some from Microsoft documentation, some are from different data professionals like Paul Randall, Aaron Bertrand. Aaron Bertrand did extensive tests with indirect checkpoints, and he had bunch of blog posts about why he could basically, he literally said there's no reason to not using it, because he had seen bunch of improvements in all over the place. So, and again, my contacts again here, and we want to thank Microsoft for supporting this this event, and also again to the organizers and the volunteers. And I also want to thank you. So the organizers are giving out a bunch of prizes. So there are ways to get prizes. You can take a selfie, post it in the hashtag. Also, there are session and conference feedback. So if you fill those up, you'll be put into raffles for different prizes.